Now we're going to look into supervision or monitoring or let's say looking into what's going on in a process, making an operator able to supervise a process. Again, it's going to be the compendium. And the compendium here is, let's say we have to go down to supervision. So it's about visualizing a process for operators. That's what it is. And how to do it depends on the task at hand. Hardware we have, they are normally computers of some sort. They can be panels, so kind of compact computers where you have the computer and the screen in one unit. It's called a panel. It could be a computer system. So that's the visualization. We have communication and we have data collection by an automation device of some sort. So that's the hardware. Now we call a human-machine interface. It's often called a human-machine interface. Yeah, it's what forms an interface between a machine. Here, automation device and a human. Yeah, and it's more or less, it's a computer program running on a computer, basically. Runs on a computer with standard operating system and standard graphical user interface. Windows, for instance. Now that's too. A little about legacy supervision, how they did it before. This is obsolete, but it can be used as, let's say, emergency supervision out in the field, so we can talk a little about it. So what it is, compressed air, that's just a pressure gauge in a panel front or somewhere, and the pressure is brought directly into the cabinet itself. And we have a pressure switch. If the pressure is high, the alarm lights up. And here's an operator, he has to follow along that. But of course, now there are measurement transducers, so this will be an electric signal, right, for the pressure switch, and they could be located out in the process. So let's say the operator is somewhere out in the plant, and he can look at, okay, here's the pressure. That's the pressure is too high or something because the lamp is flashing. Could even be a sound signal. And these instruments, as they are electric, 40 to 20 milliamps, could be connected to an output from an automation device, just for the automation device to display information out in the process. But okay, so it's legacy, obsolete. Then we got operator panel. So we replace this out in the process. We have an operator panel. So communicating using serial communication with automation devices, PLCs, and we could draw gauges or whatever on these operator panels. A lot of people do so, but it's not necessary. It can be nice for the operator to say, okay, this arrow is high. This gauge is high, it's a high value, here's something problem. It's a problem. And a flashing red, let's say, lamp on the panel could call attention, an operator or someone out in the process, attention if you're there. Whatever. But then we have computer-based system running on Windows, Unix, used Unix, but now Windows. Actually, Windows is powerful a lot. Windows Server, they're running a Windows system. I think there exists some systems too for Linux. I think they are even free, some of these, but you can check that out. But here we have operator station or clients, communicating with data servers, communicating with automation device, PLCs, doing data collection. Okay, so they are computer-based systems. And yeah, and here you can also operate on the process. It's not just supervising the process, so it's control and supervision. And then we have a system called SCADA, doing a little more supervisory control and data acquisition. So in addition, it's supervising the process, it's controlling it, and it's collecting data. Not bad. So you get all in one package. Usually the SCADA system is analogous to the client server system and not this part, but of course you need something to collect the data for you too. Important part is alarm reporting of messaging, calling an operator's attention some way. we have got alarm and pre-warning alarms. A pre-warning is something is going to go astray. It has gone astray. Alarm. So, and here are various types of binary alarms, pressure high, low. We have analog alarms, high, 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 low, 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 because they can cause more than one alarm. But these alarms are all binary, true, false. It's either an alarm or it's okay. Yeah. And they presented an alarm list shown here. So the alarm list should be use colors or symbols here, but text you should be able to read the text easily in an alarm list. There's fire in the lavatory. That's not good. Tag is a label, and then first description. We describe what it is. It's tank 1. The time when the alarm occurred. The acknowledged time here, it says receipt, should be acknowledged. Fix that. Acknowledge time. Yes, end time when the alarm is gone. The value for an analog alarm, the value it has now, so you can follow in the list how high is the temperature or whatever you want. And there's an alarm text, this one, high, whatever. The alarms are filtered. This is important. So what you want is, in this list, you only want faults that the operator can act on to do something about, mitigate the problem. If he gets an alarm that says your plant has blown up, he can't do much about it. So your tank is empty. Too bad. It is empty. I can't do much about it. Your tank is about to go empty. I can maybe do something about it. This is important. And alarm management systems and requirements for alarm systems state that you should only receive messages or alarms or pre-warnings, usually pre-warnings that you can act on. And acknowledge means this acknowledge time, and you acknowledge, I've seen the alarm and I've done what is required. Alarms, they have a priority. The alarms, they can be grouped. It's all about human factors. Enable the operator to easily assess what's going on in the process based on the messages he gets. Yeah, and then we have visual, the list, and acoustic. And here, an alarm system without acoustic alarms is useless. There's no one sitting and looking at this alarm list all the time necessarily. Give a little ding, 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 ding. Oh, look at the alarm list. Something is going on here. Acknowledge again, we talked about you have seen the alarm. I've understood what the alarm means. I have done the actions they have to do to mitigate the alarm. So the situation doesn't escalate. Yes, historical alarm list. You can go back and see what kind of messages, pre-warnings, events, and faults did he have in these systems. And then we have advanced alarms systems. Size of process system grows. More and more sensors, more and more faults. You can measure the system is more and more compact. Small group of people is controlling the entire plant. Then we have to process the alarms. We need an alarm management system to handle this, to manage our alarms. Yeah, status display, friend display. There's an XY plot with the time on the x-axis and values here, enabling the operator to say how is measurements developing over time. We have real-time trend. We can look at it and say, okay, it's heading off. Then I often get a rate of change alarm. My temperature is heading high. Do something about it. But I can look at my temperature is heading high. I should do something about it. Historical trend, we can see what were the values earlier, prior to now, way back, maybe last year. We can store values for a long time. We can document, have printouts. You can print it out on paper. You usually don't do that. You print them on PDFs and email them in modern systems. Paper, save the rainforest. We have alarm lists and alarm logs we can print out. in legacy system, you had an alarm printer that every time there was a new alarm, you could hear a matrix printer or something. You have to go over and look at it, and there was an alarm. They don't exist anymore, or shouldn't exist anymore. We have a status report about states in the process. We could print out graphics. And if you have collaboration, you have a collaboration system installed here, maybe Microsoft Teams, then you could take a snag out or print out some graphic and mail it. Of course, you have a collaboration system. You just display the screen to your colleague sitting somewhere else and say, this is what it looks like. It doesn't look good. It doesn't look normal. You are the expert. What can I do? Well, if you can't do anything about it, maybe you shouldn't be an operator in a process like this. Condition monitoring. That's the condition of equipment in your plant. And these systems, the SCADA systems, a special data system, you can supervise your equipment state. A real-time operator that's operating the process in real time does not look at the quality of the equipment. If an equipment is failing and you know it, maybe you can tell him as a pre-warning, this motor has a bad bearing, it is going to fail, it's running for now, so you should do something about it. We don't know when it's going to fail, but it will fail. So maybe you should stop this motor and start some other system or something, or stop your process and do maintenance. But what we do is condition-based maintenance, is that we know that this motor is going bad. We may have measured running hours, we have measured vibration on bearing or whatnot. And then we, this system, issue work orders or whatever, fix this bearing, replace the motor, whatever. Do whatever is required to keep your process running and avoid downtime. Yeah, so this was a little about supervision and what these systems do. Basically, it's enabling and operates. A supervision system is a view into your automation devices. They have no intelligence whatsoever, or should have no intelligence whatsoever, not affect your process, not do something automatically. That's the automation device's task, is to start and stop equipment, shut it down, and so on. So it's just a window for an operator to see what's going on in the process, but then he can also, let's say, start and stop equipment, alter controller set points, and things like that. That's supervision.